Okay, so another good one from this section is chapter 4, number 66. And this one is, a particle moves along a circular path over a horizontal xy coordinate system at a constant speed. So great, constant speed means centripetal acceleration is v squared divided by r. R is the speed, v is the speed, r is the radius of the circular path. And it says at 4 seconds, the particle is located at 5, 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it's located here. And at that point, it has a velocity of 3 meters per second in the j direction. Good, so this must be doing something like this, right? Because that's the point where the velocity is tangent to the path, so it would be following a path like this. And it goes on to say the acceleration is in the positive x direction. So that makes sense. Acceleration towards the center. At t is equal to 10 seconds, so 6 seconds later, it has a velocity of negative 3 meters per second in the I direction and an acceleration in the positive y direction. So it must have gone, let me put these coordinates here, 5, 6. It must have gone here, now it's back over to here somewhere, I don't know where, but its velocity is 3 meters per second this way, and acceleration towards the center. So it's doing something like this. I don't know the exact coordinates of this point, I just drew it on there somewhere to give you an idea that it's following that kind of a path. Good, so at this point, it's doing this and it's going in some kind of circle. My picture might not be great, but not too bad, I hope. And what we want to know is, what are the x and y coordinate of the center of the circular path over this time period? Good. So I think we already know what the y coordinate is. I mean, if it's doing this kind of a path, the y coordinate of the center, I drew this kind of out of whack here. The y coordinate of the center of the path, well, it's got to be 6. I don't know what the x coordinate of it is, though. I mean, it could be something like way over here. I just drew it like that. But at this point, that's got to be, the y coordinate at this point has to be the same as the y coordinate of the center because it's at that point. Good, so if I can find the radius, I think I can go back and figure out what this x part is of the center. And I think I can get the radius by looking at the speed. The speed is 3 meters per second. And I can use this. 3 meters per second, that's the magnitude of the velocity, the speed. It's going to be the distance it travels. And I know this distance, in terms of r, it's 3/4 of a circle. So 3/4 of 2 pi r. That's the distance here, divided by that time. And I do know that time, that's 6 seconds. Good. So rearranging this, I can figure out what r is. The magnitude of the velocity is the speed, so this is really 3 meters per second. So I'll do it over here. So 3 meters per second, try not to leave too big of a shadow. 3 meters per second is equal to 3/4 of 2 pi r divided by 6 seconds. Everything is in SI units. Good, so from this you can figure out what r is. And I'll leave it to you to do that. R is equal to something. Just a little bit of algebra. And now once you have what the actual radius is, you can figure out what the x coordinate is. Because the radius would be this distance here. So the x coordinate is 5 of this point. This is 5. The radius, whatever that turns out to be, so take 5 plus the radius, that will give you the x coordinate. So the x coordinate of the circle would be 5, this 5, plus the radius. And the radius you'll get from this. So, the center of the circle, it's centered on this x coordinate, and 6 is the y coordinate. Good. Hopefully that was helpful.